All right, what's up, guys? So we're moving on today to 8.4 trig and area. So we just did 8.2 and 8.3, which had to do with finding the area of regular polygons. So what happens when you're given a regular polygon and you do not have the apothem, so you need to find the area and the perimeter, but just by knowing what you know here. So that's what this is going to be over. So to start on the notes, as a reminder, we know that the area of a regular polygon is always 1/2 the apothem times the perimeter. So today we're going to consider the attributes of a 45, 45, 90 right triangle. Also the attributes of a 30, 60, 90 right triangle. And also we're going to consider the attributes of trig ratios, so sine, cosine, and tangent. So we're going to put all these into use to help us define the area of a regular polygon. So the first thing we're going to look at are the basic, remember what the trig ratios are. So remember we got cosine, sine, cosine, and tangent. So remember sine is always going to be opposite over hypotenuse. Cosine is always going to be adjacent over hypotenuse. And then lastly, you have tangent, which is going to be opposite over adjacent. And one way that I taught you guys to remember this are the acronyms SOHCAHTOA. So S-O-H. So S-O-H is sine. So sine is opposite over hypotenuse. Ca. So cosine is adjacent over hypotenuse. And TOA. So tangent is opposite over adjacent. And then lastly, as a reminder, remember exactly what a 30, 60, 90 right triangle is. So remember 30, 60, 90 is representing the angles of a triangle. So this is your 90-degree angle. This up here is your 30-degree angle. This down here is your 60-degree angle. So if I take my 30, 60, 90 right triangle, and I'm going to use a different color here, opposite of your 30-degree angle is always going to be your short leg, which is always going to be represented as x. Opposite of your 60-degree angle is always going to be your long leg. So to find that, I'm going to take the short leg and multiply by the square root of 3. And then lastly, to find the hypotenuse of a 30, 60, 90 right triangle, I'm going to multiply by 2 on the short leg. So these is your 30, 60, 90 right triangle. So now over here on the right side, we're going to look at a 45, 45, 90. So this is the 45, 45, 90. So remember, 45, 45, 90 represents again the angles. So this is going to be your 90-degree angle. This is going to be your 45, and this is going to be your 45. So remember on a 45, 45, 90 right triangle, both of the legs are going to be the same measurement. So I'm going to represent both of those as x. Then to find the length of the hypotenuse, I'm going to multiply by the square root of 2. So this is going to help you here in a little bit whenever we work the examples, combining trigonometry and the area of a regular polygon. All right, ladies and gentlemen, so let's do example number 1. So example number 1 states, we need to find the apothem for the equilateral triangle below, then find the perimeter and area. So right now I know this is an equilateral triangle. It's a regular polygon. So what that tells me is all the angles are congruent and all the sides are congruent. So since all the sides are congruent, I know each one of these are 15. So automatically the perimeter is going to be easy to find. So since I know this is 15, that means this side is 15 and that this side is 15. So I can either add all those up or I can multiply times 3. So 3 times 15, so to find the perimeter, I'm going to do 3 times 15, which is going to equal 45 millimeters. So that means the perimeter is 45 millimeters. So that was easy to find. So now what we're going to do is I know that all these angles are going to be congruent. So in a triangle, all of the angles add up to 180. So 180 divided by 3 is going to be 60. So every single one of these angles inside of here is going to be 60. So now, first thing that I need to do whenever I'm working a problem like this is I'm going to draw my apothem. So going from the center of my shape here, and going straight down to my side, this is going to make a 90-degree angle, and that's going to be my apothem. Okay? And so to help me define this, I'm also going to draw the radius. So your first step in doing any of these problems is to draw your apothem and draw your radius. So what I'm going to do is I'm going to draw a radius going down to this angle down here. Okay? So again, I know that every single one of these angles is 60 degrees. And from our last lesson, or actually lesson 2, this radius is going to cut this angle in half. So if this angle is 60, this angle right here is going to be 30. So now look here, this is going to be a 30, 60, 90 right triangle, ladies and gentlemen. So I'm going to be able to use my special right triangle to end up finding this. Now, if you wanted to, you could use trig, but I'm going to show you how to do it with a special right triangle here. So right now, I know that the apothem is going to cut this side in half. So if this is 15 millimeters, that means this side right here is going to be 7.5. Okay? So right now, I know in a special right triangle here, that if I have a 30, 60, 90 right triangle, 30, 60, 90, 30, the side opposite of that is the short leg. The hypotenuse is always going to be 2 times x, and the long leg is going to be x times the square root of 3. So right now, the side opposite of my 60-degree angle is going to be 7.5, which is my long leg. So that means my long leg in this instance is going to be 7.5. So I know if I go from the short leg to the long leg, I need to multiply by the square root of 3. So to go the opposite way, I'm going to end up dividing by the square root of 3. So what I'm going to do to find the apothem, I'm going to take the long leg, which is 7.5, and I'm going to divide it by the square root of 3, which mathematically this isn't correct, but you can type this in the calculator, it will give you a decimal. So if I do 7.5 divided by the square root of 3, so I'm going to do it right now, 7.5 divided by the square root of 3, it is going to give you 4.33. So ladies and gentlemen, this is going to be your apothem. And so lastly, now what it wants me to find is it wants me to find my area. So lastly, I know to find area, it's going to be 1/2 the apothem times the perimeter. So all I got to do is plug everything in. So 1/2, my apothem is 4.33, and then my perimeter is going to be 45. And so whenever I multiply all this out in my calculator here, it is going to give me a final area of 97.43 millimeters squared. So ladies and gentlemen, your area is going to be 97.43 millimeters squared. So I'm taking everything that I've learned in the past few lessons and what we learned a little bit last semester and tying it all into one problem. Alright guys, so now looking at example number 2. So example number 2 says we need to find the apothem for the square below, then we need to find the perimeter and the area. So we're finding the apothem, the perimeter, and the area. And so right now if you look, this is a regular polygon because all the sides are congruent and all the angles are congruent. So it makes it a regular polygon. So and the only information they've given me here is going to be my radius, or my radii, whatever you want to call it. Okay, so now what I'm going to do, I told you earlier, the first thing whenever you're working these type of problems is you need to draw your radius, which is already drawn, and then we need to draw my apothem. So I'm going to draw a line going straight down, and I know this is going to make a 90-degree angle. Okay, and so ladies and gentlemen, I know that if I have a square, I know all these angles are 90 degrees. So I know that this radius is going to cut this angle in half. So half of 90 is 45. So that means this angle down here is going to be 45. Which now makes this a 45, 45, 90 right triangle. So I know in a 45, 45, 90 right triangle, I'm going to draw one over here. This is 45 and this is 45. Both of my legs are going to be congruent, and my hypotenuse is going to be the square root of 2 times my leg here. Okay? So look, I'm given my hypotenuse, which is 12 centimeters. I know in a regular 45, 45, 90 right triangle, I know to go from the leg to the hypotenuse, I have to multiply by the square root of 2. So to go from a leg to the hypotenuse, I have to multiply. So now to go the other way, I have to end up dividing. So what I'm going to do to find my apothem, which is this guy, to find the apothem, I'm going to do 12 divided by the square root of 2. Which, if I did that in the calculator, 12 divided by the square root of 2 is going to give me 8.49. So 8.49 is going to be my apothem in decimal form. So 8.49 is my apothem. Okay? So now I know in a 45, 45, 90 that these two are going to be congruent. So if my apothem is 8.49, that means this side down here is 8.49 as well. I know the apothem cuts this side in half, so if this is 8.49, this is going to be 8.49. So 8.49 times 2 is going to be 16.98. So that means this whole side over here is going to be 16.98. So now to find my perimeter, I know there's 4 sides, so I'm going to multiply that by 4. So if I multiply that by 4, my perimeter, so to find the perimeter, I'm going to do 16.98 times 4. And if I multiply that times 4, I would get 67.92. So perimeter is going to be 67.92. So now lastly, to find the area, I know to find area of a regular polygon, I would take 1/2 the apothem times the perimeter. So 1/2, the apothem is going to be 8.49, and then my perimeter is going to be 67.92. So if I multiplied all this out, so 0.5 or 1/2 times 8.49 times 67.92, that's all going to work out to be 288, and I think my measurement is in centimeters squared. So ladies and gentlemen, this is how you use a special right triangle to solve for your values here. Okay, and lastly on example number 3, I am given a pentagon, and I need to find the apothem, I need to find the perimeter, and I need to find the area of this regular pentagon. So right off the bat, I know since I have a regular pentagon, I know all of my sides are going to be congruent. So I can go ahead and find my perimeter. So I know there's 5 sides, so to find the perimeter, I'm going to do 5 times 10, which is going to give you 50. So automatically my perimeter is going to be 50 inches. Okay? So now in order for me to find my apothem, I need to first draw the apothem and my radius like I talked about in the other 2 examples. So what I'm going to do is I'm going to use a different color. So from the center, I'm going to draw a line going straight down to my side, and that's going to be 90 degrees. Then I'm going to draw a line going to my angle, which is going to be my radius, correct? So I know the apothem cuts this side in half, so that makes this side 5 and this side 5, automatically, okay? And so now, what I'm going to do is I'm going to use the interior angles of my pentagon here to figure out what my missing angle is going to be here. So I know I have to take the number of sides, subtract 2, and multiply by 180, then divide by the number of sides to figure out what one of these angles is going to be. So in a pentagon, there's 5 sides, so I'm going to plug 5 in for the end, 5 in for the end. So 5 minus 2 is 3. 3 times 180 is 540. So I'm going to do 540 divided by 5, which is going to come out to be 108 degrees. So that means every single one of these angles is going to be 108 degrees. And now, I told you guys before, the radius is going to cut that angle in half. So this radius is going to cut this 108 degree angle in half. So half of 108 is going to be 54. So that means this angle down here is going to be 54. So what I'm going to do now is I know this leg right here, and I need to find the apothem. So I'm going to use some trig to find that. So going from this 54 degree angle, and I'm actually going to draw this triangle a bit bigger so we can see it. So this is a right angle, I know this is 5, I know this is 54, okay? So going from this angle, this is my opposite side, okay? Opposite of the right angle is always going to be my hypotenuse, so this is my hypotenuse, and so this makes my adjacent. So I know my adjacent side, I need my opposite side. So going back in your notes, opposite and adjacent is going to be tangent. So tangent is equal to opposite over adjacent. So let's go and plug in what we know. Tangent of what degree? 54. So I'm going to do the tangent of 54 is equal to the opposite, that's what I need, which is my apothem, over the adjacent, which is 5. And so literally, in order for me to get the x by itself, all I have to do is multiply by 5 on both sides. So x is going to be equal to 5 times the tangent of 54. So let me go ahead and see what this guy is. So I'm going to do 5 times trig, tangent of 54, and when I click enter I should get 6.88. So x is equal to 6.88. So that is going to be the value of my apothem. So my apothem is going to be 6.88 long. Okay? So now I know my perimeter. Now I know my apothem. So now I know I can find my area. So again, I know area is 1/2 the apothem times the perimeter. So in this instance, the apothem is 6.88. My perimeter is 50. And so when I multiply all of this out, 6.88 times 50 times 1/2, I should get 172. So my answer is going to be 172 inches squared. So ladies and gentlemen, any part of these problems that you're working, you can use trig on any one of these problems. But if you're given a 45, 45, 90, you can use that. If you're given a 30, 60, 90, you can use that as well. Please ask questions if you need help. I know some of this is a little confusing at some points, but ask for help and I will help you at any point you need it.